So for this week, we're going to continue with the ride-sharing simulator. Starting with the function, we have self x, y, w, h. X, y are considered the center of the rectangle, and w is the width, and h is the height. So we have then the contains function, self and point. We're going to check if point is inside the rectangle boundary, either horizontally or vertically. And then we have the distance to point. We're going first to calculate horizontal distance from point to rectangle edge, 0 if is inside, and then calculate vertically distance from point to rectangle edge, 0 if it's inside. And then we're going to use the Euclidean distance from point to the closest edge of the rectangle. Going to the Quadtree node, we have the children nodes. We're going to start with all of the 4 of them, none. And then we're going to do the subdivide function, which is creating a child node for each of the previous children. Then we're going to insert, first we're going to ignore points outside this node's boundary. That's if it's false, and if it's true, going to add point if capacity is not reached. Either or else subdivide if not already done. And then we're going to try to insert into each side node and return true if successful. Going to the find nearest function, calculate distance from core points to this node's boundary rectangle. For loop to check each point in this node for closer candidate. We're also going to use Euclidean distance from the point to query point. And then if subdivided, check child nodes recursively. Then search each child node in order. And then lastly, return best point found and its distance. So we have the class Quadtree, the main function, root node of Quadtree, and then insert point starting at root, and then we have the find nearest point starting at root, and then return the nearest point found. So we're going to go to the test Quadtree. So we're going to import from the Quadtree file, the previous file, and just checks every point and picks the one closest to our target, which is the brute force function, nearest function. And then we have the main functions here, make a big square area where all our points will live, centered at 500.500, and then create a Quadtree with the boundary so we can insert points smartly. And then generate 5,000 random points spread across the area 0 to 1,000 range. And add each point into the Quadtree for faster searching later. Pick a random spot to search from, 0 to 1,000, and then use the nearest Quadtree to quickly find the closest point. And then use the brute force, the slower but to find the closest point, and we're going to show at the end the results. Here we have to make sure both methods gave the same results. So let's go and run this program. Yes, here, so the query point is 952 and point this long number and 734. Here we have the nearest by Quadtree, and the nearest by brute force give us the same number. So as we said here, we should make sure that they are the same, which they are. Okay, thank you.